Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video explains the relationship between significance levels and critical values. Let's get started. So we've seen in previous mini lectures that the significance level is simply the probability of getting a type 1 error. And a type 1 error is rejecting a null hypothesis when it's actually true. So this is chosen as an initial assumption for the hypothesis test. This is simply the way that it's set up. So there's no need to understand why that is. You just accept that and move forward with that assumption. Usually the consequences of having a type 1 error will determine what the significance level is. So the more serious the consequences of committing a type 1 error, the more small the significance level is going to be. So the significance level, which we represent with the Greek letter alpha, is going to determine the size and hence the boundary of the critical region. Remember that the significance level, alpha, is going to be the area under the curve and the tail of the distribution, and this is going to be bounded by the critical value. So here in our distribution, we have an area in the tail of the distribution that represents the significant level alpha. And the boundary of that area in the tail is going to be the critical value. This provides us with the critical region, which is also known as the region of rejection, because this is what we're going to use to determine whether or not we're going to reject the null hypothesis or fail to reject the null hypothesis. So these critical values are the boundary for the critical region in our distribution. Now, this critical region is important, okay, because as I just got done explaining, it's a standard we're going to use to conclude our hypothesis test. So we have a region of rejection in the tails of the distribution. So whether it's a one-tailed test or a two-tailed test, that significance level alpha is going to be the area in the tail, and the boundary of that area is going to be the critical value. Let's look at an example to illustrate what we've learned so far. So if we're given a test statistic, z equals negative 1.23, and the alternative hypothesis is that p is less than 0.5, what is the p-value? Well, in this instance, we're going to go to our normal calculator in StatCrunch. We're using the normal distribution because we have a test statistic as a z-score. And z-scores come from the normal distribution. Notice this is a standard normal distribution because the mean value is 0 and the standard deviation is 1. This is what you want. So now that we have the standard normal distribution, so now we're going to actually put our z-score in. This is the test statistic. Remember, the test statistic provides the boundary for the p-value. So this area that's underneath the curve is going to be the p-value. So we want the area to the left because that's going to make this tail of the distribution. That's going to be our p-value. So there's our less than sign for our inequality. There's our z-score, and then out comes the area under that curve, and that area is going to be the same as the p-value. So the test statistic goes there on the left. The p-value is there on the right. And it is the area there in the tail of the distribution bounded by the test statistic. Notice we have a left-tailed test. This is how we know we want the tail on the left and not going to the right of the test statistic, because our alternative hypothesis has the inequality sign of less than, and that's like an arrow pointing to the left. So we know we have a left-tailed test. And so we're going to adjust that calculator in StatCrunch accordingly. We want that left tail of our distribution to be the area that is the p-value. What's the critical value when alpha is 5%? Well, again, we can go into StatCrunch and put in the 5% there for the area, and then out comes our critical value, which is the boundary for the critical region, which is, the area that is the alpha, or the significance level. So there's our alpha, 5%. That's a significance level, and that area is bounded by the critical value, which you see there on the left. So critical value on the left, significance value, significance level there on the right. Let's look at another example. Suppose we have a test statistic of negative 1.75 is obtained when testing a claim that P equals 1/3. Well, they didn't give us what we're looking at, whether it's a z-score or a t-score or what have you. But if the claim is that the proportion is 1/3, the test statistic for proportions is a z-score. So we know we're going to use that standard normal distribution. So in StatCrunch, we get the standard normal distribution and look at the values that we're putting into our calculator. So again, that test statistic is going to go on the left and the p-value comes out on the right. Okay, so here's our test statistic, negative 1.75. But this value here is not the p-value because, again, look at the claim. The claim is that proportion equals 1/3. Well, that means that our alternative hypothesis is going to be P is not equal to 1/3. And the not equal in the alternative hypothesis means we have a two-tailed distribution. So what we're looking at here in our calculator in StatCrunch is only half of the p-value. We're looking at the left half. We need the right half as well. Well, because the normal distribution is symmetrical about the center, the area on the right is going to be the same as the area on the left. So if we just multiply that area by 2, we get the value that is the p-value, 0.0802. So again, looking at that claim and recognizing where alternative hypothesis is leads us to the correct solution. Now, because we have a two-tailed test, we could use that between option, okay, and get to two tails. But then we're going to have to recognize that this area that comes out, the 0.91988, this is actually the area in between the tails. We want the area of the tails. So to get the area of the tails from this, we'll have to subtract this from 1. But notice if you take 1 minus this number, the 0.9198, you're going to get 0.0802 coming out. So either way to work this is going to get you to the right answer. What's the critical value when alpha equals 5%? Well, again, we put that into our calculator there in StatCrunch and we come out with 1.96 for a critical value. Again, two-tailed distribution, so we've got 95% of our area in between the tails, and the area of both tails together is our significance level. That's going to be 5%. So we're going to have to, remember, put that confidence level 1 minus alpha in for your area to get the correct horizontal values out for your critical values. And of course, because there's a two-tailed test, we have two critical values, one positive and one negative. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.